Welcome to our next lesson on solving equations with variables on both sides of the equation. So let's take a look at a couple word problems, then we're going to take a look at a couple cool, fun cases with the variables on both sides. So let's start off with this example. A polygon is called regular if each of its sides has the same length. Find the perimeter of the regular polygon. So this is a regular triangle. And by regular, it means that all sides are the same length. So in order to find the perimeter, I need to find out the length of each side. So I need to find out what x is so I can find out the length of this side. Now what it told us is that the sides have the same length. So that means 5 minus 2x has the same length as negative 4x plus 9. Alright, so now I need to go ahead and solve for x. So negative 2x is bigger than negative 4x, so I'm going to keep the negative 2x and add 4x to both sides. And notice when I do that, I end up with a positive 2x. So 5 plus, now I have a negative 2x and a positive 4x is a positive 2x, is equal to a negative 4x and a positive 4x goes to 0. And I'm left with 9 on the right. So now I can subtract both sides, or 5 from both sides, since now I have a simple two-step equation. So 2x is equal to 9 minus 5 is 4. Now isolate the variable by dividing by 2, and x is equal to 2. So now that x is equal to 2, I can substitute it into either of these equations to figure out the side length. So let's go ahead, I'll substitute it into 5 minus 2x. So that's 5 minus 2 times 2, which is 5 minus 4, which is equal to 1. So each of these side lengths is of length 1 unit. Because it's a regular polygon, so each side has the same length. Just to double check if you wanted to, you could put 2 into this expression. Negative 4 times 2 is negative 8, plus a positive 9 is also 1. So to find the perimeter, we're going to add up the three sides, s plus s plus s for sides. So the perimeter is equal to 1 plus 1 plus 1. So the perimeter is equal to 3 units. Alright, let's look at another example here. Alright, so this is kind of a fun one. Your cell phone provider offers two plans. So back in the old days, they didn't just have unlimited plans. You actually had like a monthly fee and then a cost per minute or even per text back in the day. So what we want to find out is comparing plan A and plan B, write and solve an equation to find the number of minutes you must talk to have the same cost for each of the plans. So we want to know, when is plan A equal to plan B? So let's go ahead and let M equal to the number of minutes talking, let's say. Alright, so plan A says that we are going to pay $15 no matter if we talk no minutes or a million minutes. So $15 plus, and then it's going to cost us 25 cents per each minute for plan A. And we want to know, when is that equal to plan B? When is that equal to plan B, which is $20 for the month, no matter how much you talk, but it's at a lower rate even though you pay more up front. You only have to pay a nickel per minute. Now notice we have a equation with variables on both sides. So let's see, 0.25 is bigger than 0.05, so let's go ahead and solve this. I'm going to subtract 0.05 m from both sides. Alright, so we have 15 plus, this turns into 0.20 m, or 0.2 m is equal to 20. Now subtract 15 from both sides, and we get, I'm just going to change this to 0.2 m is equal to 5. Now divide both sides by 0.2. Alright, so 5 over 0.2. This is the same if I move the decimal point one place to the right, same as 50 over 2. So that means 5 over 0.2, or 50 over 2, is equal to 25. So you must talk 25 minutes to have the same cost. Right? And again, in the old days, we would try and figure out, well, how much do we talk in a month? And that would determine what plan we would do. So if we we're going to talk for like only 10 minutes, then it would make sense to do plan A. If we're going to talk 100 minutes, more than that 25 minutes, we would do something like plan B. All right, so let's go ahead and take a look at a couple of exceptional cases when solving equations with variables on both sides. So let's look at this first example. We have 3 minus 4x is equal to negative 7 minus 4x. So I want to get the variables on one side of this equation. So I'm going to add 4x, but these are both negative 4x. So look at what happens. I'm going to try and add 4x. What I do to one side, I have to do it to the other. Well, I have 3, and a negative 4x and a positive 4x, that's 0. So 3 is equal to negative 7. A negative 4x and a positive 4x, that goes away. So now I have 3 is equal to negative 7. Well, 3 is never equal to negative 7. So when you come into a case where your variables, your terms with the variables, both cancel out, and you end up with a statement that is untrue, that will never be true, there is actually no solution. You will never, ever, ever be able to find a value for x where this will be true. You can kind of see that. If we have a negative 4x here and a negative 4x, no matter what we put in for x, if we put in 1 or 0 or 10, adding 3 to one side and adding negative 7 to the other side just is not ever going to be equal. So that's one case when you try and move the term of the variable and they both go away and you end up with a false statement. What happens in a different case? So here we have 6x plus 4 is equal to 4 times 3 halves x plus 1. So let's go ahead and distribute. So we have 6x plus 4 is equal to 4 times 3 halves. Well, the 4 and the 2 simplify to 2 and 1. So 2 times 3 is 6x plus, now this was a 4 still, that was just distributing there. So now let's look at the 4 to the 1 is just plus 4. You can see something very peculiar right now. These both are the same equation. Right here, this tells us no matter what I put in for x, these expressions will always be the same. So let's just see what happens if I subtract 6x from both sides. What's left on the left is 4, and what's left on the right is also 4. So 4 is always equal to 4, no matter what I put in for x. I could put in any number that I want. I will always get expressions that are equal to each other. So in this case, I have infinite number of solutions. So you just write infinite solutions. That means no matter what I put in for x, I will get a true statement. All right, so here's some on your own. I've got 4 in total for you. So give that a try. Here's the first one, A. All right, so that would be a no solution. 1 is never equal to -1. Let's try the next one. All right, after distributing that 1/2, you'll see that both sides have an expression of 3t minus 2. So that's going to tell us we have an infinite many number of solutions. So infinite solutions for that one. Here's C. Go ahead and distribute and then solve. All right, so after distributing, we have 30 minus 12v is equal to -12v plus -4. So if we add 12v to both sides, we get 30 equals -4, which is never true. So that's no solution. And last but not least, we have D here. All right, after distributing, we have 2b plus 3 equals, or 2/3 b plus 3 is equal to 2/3 b, and then 2/3 times 9/2 is also 3. So after subtracting 2/3 b from both sides, 3 is equal to 3. That is always the case, so we have an infinite number of solutions. All right, well, that'll do it for our lesson on solving equations with variables on both sides.